What's up, Hippie Bio Penguins? So today we are going live for just a quick moment and we're going to go over Chi-Square. So again, hi. Hope you are having a wonderful day. We're going to look at Chi-Square real fast because I promised somebody I would do it. And then later on tonight, we'll come back on and do our FRQ. So I'm going to go through Chi-Square pretending like you know nothing. And because I feel that some students who might need a little bit more support need to see all the steps. So just kind of bear with me since I'm going to go through all of the steps with it. So it says we're going to do a chi-square based on a genetics problem. Okay. So you cross two yellow round heterozygous peas. So it says, I know that they're heterozygous. What that tells me is that, we are looking at yellow and round are both a dominant trait and that they're both heterozygotes. So we're going to be doing a dihybrid cross or a cross between two heterozygotes for two traits. And we want to know, does this follow independent assortment? And then it tells me how many you have. I've got, 219 that are yellow round, 81 that are round green, 69 that are wrinkled yellow, and then 31 that are wrinkled green. Okay, so the first step you're going to need to do is you're going to complete a Punnett Square. Okay, so when you do your Punnett Square, you'll put your two different traits on there. So of course, we're looking at a heterozygote for the yellow and heterozygote for round. Okay, we're going to cross these. Okay, so my big idea whenever we do any type of dihybrid cross or tetrahybrid or however many crosses we're looking at and however many traits we're looking at is to always bring it down to the mono cross. Always do a 2x2 square and then you can multiply from there. Okay, so never try to do one of those big 4x4s that gets a little too complicated. It takes a little too long. When we get to the AP exam, you're going to need to be able to do your math quickly. So you want to do the 2x2s and follow your probability rules. Okay, so when we do that cross, we see that 3/4 of them are going to be yellow. See, these three right here are all yellow. And this one right here is green. If we did this cross down here, we would find that 3/4 of them are round and 1/4 are wrinkled. Okay, well, we're not done. We need to figure out how many of them have the two traits. How many are yellow round? How many are green round? How many are yellow wrinkled? And how many are green wrinkled? I missed one. You know what I'm following, okay? So you're going to follow those same probability rules and you're going to multiply them, okay? So when we looked here, we said, well, yellow is 3/4. So yellow round is going to be 3/4 times the 3/4 for round, which gives me 3 times 3, which is 9. 4 times 4 is 16. Okay. If I want to know yellow, 3/4 times wrinkled, 1/4. 3 times 1 is 3. 4 times 4 is 16. Green is 1/4. And round was 3/4. So 1/4 times 3/4 gave me 3/16. And then if I wanted a green wrinkled, green is 1/4 and wrinkled is 1/4. So 1/4 times 1/4 gave me 1/16. Okay. And so that tells me that overall I should see a 9-to-3 to 3-to-1 ratio whenever I'm doing my, chi-square for this, okay? I would expect a 9-to-3 to 3-to-1. Okay, well, how do I apply that to this big thing? So I always tell my students to use this chart, okay? So when you make your chart, you'll put all of your phenotypes on one side. So I have a yellow and round, yellow and wrinkled, green and round, green and wrinkled. We're going to have the observed and then the expected column. You're going to have a observed minus expected, observed minus expected squared, and then observed minus expected squared over expected. All this is doing is breaking down the formula into its components so you can do it in a stepwise function so that you're less likely to make errors, okay? Yes, I know we all know how to use our TI calculators. Yeah, we can just type it all in and just hope for the best. Let's be sure that we don't make any type of errors, okay? Chi-square is one of the science practices we need to know for the AP exam. So we need to make sure that we know how to do it. And we also need to make sure that we understand what that number means, okay? So let's get started. So in our chart, we filled in our observed because we found out we had 219, 81, 69, and 31. All I did was take the values that were given to me in the equation, and I just slotted them into the chart, okay? So in order to figure out my expected, I'm going to use the ratios that we found. We found that 9/16 were yellow round. I have a total of 400 P's. So I'm going to do 9/16 times 400. And so there should be 225 that I expect. If you were to get a decimal here, I believe you need to keep that decimal. Okay, look at whatever your answer is supposed to be in and round to 1 decimal past it. So if you're supposed to give it to the 10th place, keep at least to the 100th place in it. If you're supposed to give it to the 100th place, keep at least to the 1000th place. The reason I say this is because it will eliminate your rounding errors, and the farther off you get from the answer due to rounding issues, the higher the chances that you're not going to get it right. Okay. So if we do our next one, yellow and wrinkled, we saw was 3/16. So again, 3/16 times my total, which was 400, gives me 75. If I want to do a green round, that's going to be 3/16 times 400, again giving me 75. All I'm doing is applying my probability rule, where I say that, okay, well, 1/6 of them should be green wrinkled, and then times the 400 total should give me 25, okay? So now we go to our next column. Observed minus expected is what we're doing, right? So my observed is 219 minus my expected 225 gives me -6. 69 minus 75 gives me -6. 81 minus 75 gives me 6. 31 minus 25 gives you 6. Okay, so all we did was take this column and we subtracted this column, and that gave me this column. Okay, so your next thing, you're going to take this column and you're going to square it. So 6 squared we know is 36. 6 squared is 36. 6 squared is 36. 6 squared is 36. Oh, look, there's a typo. That should not be negative, and neither should that one. Sorry, y'all. But so we're just looking at that. We're just going ahead and squaring the number we had over here to get this value. And last but not least, you're going to take your observed minus expected squared, and you're going to divide it by your expected. Okay, so we're going to take 36 divided by 225, and that gives me 0.16. We'll take 36 divided by 75, and that gives me 0.48. We take 36 divided by 75, because again, we have 36 and 75. And last but not least, 36 divided by 25, which gave me 1.44. So the final number is going to be our chi-square. We add all these together. So we do the 0.16 plus the 0.48 plus the 0.48 plus the 1.44, and you get a value of 2.56. Yay! We're done! We solved for chi-square. But what does it mean? It means, I don't know what it means. We got to figure that out. Okay. So our next step is we have to compare it to our null hypothesis. Okay. So our null hypothesis is basically telling me that whatever we think happened didn't happen, right? So if we're looking at some type of treatment, the treatment makes no effect. If we're looking at genetics, the population follows independent assortment. If we're talking about Hardy-Weinberg, it follows the Hardy-Weinberg equilibrium. It's basically saying that whatever we think is going to happen, it has no effect, right? So we should get our values to be the exact same as we expect them to be when we observe them. We should have very close numbers, okay? So in our case, we're looking at, does the experiment follow that 9 to 3 to 3 to 1 ratio, and does it show us independent assortment, okay? So we need to first find out what is our degree of freedom. Our degree of freedom is the number of samples we have minus 1. So I have 4 different phenotypes. So I say 4 minus 1, so my degree of freedom should be 3. If I look at my chart, I say, okay, well, degree of freedom is 3. I have a 5% probability, or a p-value of 0.05 of 7.81. So how does my chi-square value compare to this value? Well, my chi-square is less than that, okay? So 781 is greater than 256. So my chi-square value is less than the table value, which means that I will accept my null hypothesis, which means that I am demonstrating a 9 to 3 to 3 1 ratio. My sample followed independent assortment, and that is how I'm able to say, okay, these two traits were not linked. And so I know they're on 2 different chromosomes, or they are far apart on the same chromosome that they would act like they are not linked. So I hope that was helpful, and I will see y'all this afternoon, this evening, for our FRQ Friday. So remember, your AP Bio Penguins and your Desk for Success. Have a good day. Bye.